Hello everybody and welcome to this presentation entitled Getting Started with AutoCAD 2014 JavaScript API. My name is Philippe Lefma and I'm working for Autodesk Developer Technical Services. This presentation targets programmers and software developers who have little or no knowledge with the JavaScript as a language, and for those who want to get familiar with the new JavaScript API being introduced with AutoCAD 2014. And here is the agenda for this presentation. We will go through an introduction to JavaScript as a language. We will then present you the JavaScript API for AutoCAD itself, and then several ways to extend this JavaScript API either from .NET or Object-IRX. Let's start with the first part, the introduction to JavaScript. So what is the JavaScript language? This is a straightforward scripting language that is used mainly for client-based web development. JavaScript is not related to Java other than in its name and general approach of using the C-like syntax. Originally developed at Netscape under the name Mocha, it was later renamed LiveScript and nowadays JavaScript. So a few words about the JavaScript structure. This is a dynamic weakly typed language. That means that the types are associated with values and not variables, allowing a variable to change type as needed. It's as well a prototype-based language, which means that it doesn't use classes to define object properties, but prototypes, which includes methods. And finally, it's a function-based language. So the functions are treated as objects with properties themselves. It means that, for example, functions can take other functions as arguments or returns functions as value. So why JavaScript is so popular? First of all, as I mentioned previously, it has a C and Java-like syntax, which makes its learning curve very straightforward for programmers knowing one of those languages. As well, it's considered as the language of the web because it enables dynamic HTML scripting. On the server side, for example, there are various options in order to write server code, but on the client side there really is just one option, and this is JavaScript. As well, it provides Ajax, which is a set of technologies that enables working with asynchronous web services. And originally as well, it's using the JSON data format, that is an elegant data exchange format that is nowadays used in most of the web services all over the web. So which are the tools and the IDE that you can use in order to work with JavaScript? There are many tools, but here are a couple of free tools that you can easily download and try over the web. The first one is the NetBeans IDE. I will show you a bit what it looks like. Then there is the Visual Studio Express 2012 for web, that is as well a free compiler or IDE development environment. And Firebugs, that is very useful plugins for Firefox that I will as well demo later on. So here is our first JavaScript code sample. Coding with JavaScript requires the code to be embedded in the HTML script and /script tags. You can see there a quick sample that is using the alert function in order to display a message. So let's take a look at how this code looks like in NetBeans and how we can execute it in the browser. So here is the NetBeans IDE, and you can see I was typing these quick JavaScript samples with the alert methods. So in order to run this code, you need to open this HTML page inside any browser. So here I've got Firefox running, and you can see I've got this HTML page open over there. So I'm going to refresh that page, and you can see this dialog message appearing. The other alternative in order to write JavaScript code is to use a JS file. So you can write your JavaScript code inside a specific JavaScript script file. In that case, I was creating this very simple function that is going to display the same alert dialog, but taking a name as input parameter. You will then reference your JavaScript file inside the head section of your HTML document. This is what I did over there, and then you will be able to run this JavaScript code from a script inside the HTML document. In that case, I'm invoking that function and passing it the name as a parameter. So when running that second example, you will see the same dialog appearing with now my name. Let's now take a look at the Firebug add-in in order to illustrate how you can debug that JavaScript code when running inside the browser. So here is the Firebug add-in icons. I've been installing that previously, and when clicking on that icon, it displays the Firebug console that allows you to do many things. For example, analyzing the HTML element you have in the web page. You can select some specific elements you want to analyze in detail, and in that case we're going to place a breakpoint inside this JavaScript code. So I need to reload that page, for example, and here is the source of our HTML page. I'm able to set a breakpoint upon this function call, and when refreshing the page, then you can see that the breakpoint gets hit. As in the classic debuggers, you can analyze the live values of the your variables. So you can see here the various elements of the browser. If I declare some specific variables inside my script, then you have the ability to select a specific variable and watch its value. And as well, I can step over or step into the various methods that are getting called. In that case, I'm going to step into my method call, and you can see that it takes me inside this method I was declaring in the other JavaScript file. Step over that method takes me back to the HTML page. So let's get back to our presentation and a few words about the JavaScript variables. Because JavaScript is not a strongly typed language, you can simply define the variable name and give it a value. Later on, you can reassign a different value of a different type to the same variable. In that case, we are defining doubles, strings, integer, and in the case of the last variable, it has no value and as well no type, as long as it doesn't have a value affected to it. Concerning arrays, the JavaScript has a zero-based array indices, and value can be provided either during initialization or later on. Functions are used by simply calling them by the name with the argument specified if needed. The declaration of your function is usually done inside the head section of the HTML page or inside the separate JavaScript script file as I illustrated previously. If you want to go deeper, here are a couple of interesting books you can either find on the web or order. The first one is the JavaScript The Good Parts by Douglas Crockford, The Definitive Guides of JavaScript by David Flanagan, and the Eloquent JavaScript by Margin Averbicki, that you can as well find as an HTML version over the internet. Let's now take a look at the JavaScript API inside AutoCAD. The idea behind this JavaScript API for AutoCAD is to open it to the JavaScript web developers. You will be able to load a JavaScript-enabled HTML page into a tool palette or a dialog inside AutoCAD. As well, the same API will be shared by AutoCAD WS. So basically the same code based on JavaScript will be able to run equally inside the AutoCAD user interface and the AutoCAD WS interface. The other thing concerning security is the introduction of a new system variable called trusted domains that will control the fact that an HTML page being loaded will display a security warning dialog to the user, allowing him to authorize or cancel the loading of this HTML page if it's not part of a trusted domain. You can obviously edit this trusted domain variable in order to add the specific domain on which your HTML page is running. Here are the various features of this first version of the JavaScript API, grouped by categories. The first one concerns prompts, inputs, and jigs that will allow the programmers to write JavaScript codes in order to grab the user inputs and select entities and other related activities like dragging through the jigs. Transient graphics, the JavaScript API will provide functionalities in order to draw temporary graphics on the graphic window. System variables, so the API will provide functionalities in order to read and write any system variables inside AutoCAD. View manipulation, you will have the ability to either read the view properties or set the view properties for the current view. You will be able to define JavaScript commands, and then those commands will be able to run from the UI as any other AutoCAD command. Dialogues, so the JavaScript API provides functionalities in order to display several dialogues, modal or modeless dialogues. You can listen to database object events, and as well it provides bindable object collection that are specific JavaScript object that will monitor changes for some specific collection, such as the table records. Finally, the application object provides a set of miscellaneous functionalities. In terms of resources, you will be able to find the JavaScript API reference at this address, and the JavaScript API itself is provided as a single online JavaScript file that you can find at this address. So you can simply reference that JavaScript file inside your HTML document in order to start using this API. So let's take a look at the JavaScript API reference. So here is how this documentation looks like. So we take a look at the content. You have here a very short reference guide that for the moment only contain a few information about how to extend the API, so from Objective-RX and .NET, but we will come back on this topic in the third part of that presentation. And you can see here pretty much all the functionalities are grouped under the AutoCAD namespace. So you've got here access to all the functions and objects, so we can take a look, for example, at the AutoCAD prompt option, and we can see here that it has a very similar look and feel to the .NET help file, for example, where you can find the function name, the various parameters that it takes, and a quick description of what it's doing, that specific object or method. So let's now take a closer look at a concrete sample of the AutoCAD JavaScript API. First of all, you will be able to find the set of samples provided with that recording inside the sample directory, and I'm going to show you the AC.html part of those samples. This folder contains a .NET project that is pretty straightforward. I'm not going to step into that code, but mainly it contains .NET code that will display a specific palette that allows the HTML web page or local page to be loaded. Then inside the unit test folder you will find several directories that contain the unit test for the JavaScript API. Each directory contains an HTML page and an associated JavaScript file that contains the JavaScript AutoCAD code. So let's take a look in that case at the DB reactors that illustrates the database event functionality. The first thing in my HTML page is the referencing of the JavaScript API that you can see there. So that's the online file I pointed out previously. And then the second script reference is my JavaScript code itself for AutoCAD. The HTML code, is pretty straightforward. So it contains two buttons, one that will allow the user to select entities and one that will stop the observation of the events, as well as two text areas, one that will display the IDs of the entity being observed and one that will log the various events that may happen to those database objects. Concerning the JavaScript code, it will probably look familiar to .NET developers. So in that case of the select entity method, you can see that I'm creating a prompt entity option in order to set the various options and properties for the input, the message and keywords, the reject message, and then some optional properties like the single pick in space or allowing the user to select object on locked layer. And because this JavaScript API is asynchronous, you need to provide callbacks whenever you call a method that is going to be blocking. So in that case, the get entity, you will provide the onComplete and onError callback that will be called if the function succeeds or fails. And inside the onComplete code, you can see that it takes as parameter a string that is a JSON string, so you can find the built-in functionality JSON parse that will convert that string into an object. And then you can start calling properties or methods on that object. So in that case, we will check the status to see if the call succeeded. Then we will create a collection of observed entities, so that variable is declared here as an AutoCAD object set. And this will allow us to add the object ID of the selected object. Once our collection is filled, we can pass it to that static method AutoCAD application active document start observing. We'll pass our object set, we'll pass the kind of event we want to listen, so in that case object modified, and we as well provide a callback that is fired when this object is getting modified. The same for this object erased. Inside the object modified, you can see that we will access the specific text area of our HTML document using the getElementById method, and we will append the object ID of that object being modified. So let's take a look at how it looks like inside AutoCAD. I'm using my ADN.js demo command. That method is being defined by my iris, and it allows me to select a specific HTML page on the disk, in that case the DB reactor. Here you can see the result of my HTML page being displayed inside the palette, and I'm going to create some entities in order to select them. When I click the Add Listener, then my Select Entity method is being invoked, and I'm able to select an entity in the graphic window. You can see the object IDs of my entities are appearing here, and whenever I modify or suppress those entities, then you can see that my callbacks are being triggered. Modify the circle or delete that line. Let's take a look now at the other samples that are available with the attachment. Here is a sample illustrate the creation of image previews from the database. So in that case, you can see I can create an image of the selected width and height, and when I click the capture preview, this image is created on the disk and then inserted inside my HTML document. Let's try different sizes. And here we go. Other samples concern the selection of entities and various inputs, so I'm not going to go through all of them, but for example, the prompt sample illustrates the various selection prompts you can use, for example, the prompt corner, the prompt point, integer, double, distance, and so on, and you can tweak dynamically through the HTML page the various properties of that selection here. So just going to illustrate the corner in that case. You can see the result of that selection as a JSON string that we can then parse through our JavaScript code in order to access the various properties. The system variable sample illustrates the use of the system variables. So we can here enter a system variable, for example, the file dialog, and get the value of that variable, in that case 1. We can set the value through the API. So to set the value here, you can see now the value is 1. And I can as well add the listener for this variable, so whenever I change the value either from the API or inside AutoCAD, then this callback will be triggered. So in that case, I'm going to set that back to 1, and you can see here that my callback has been invoked. The next sample illustrates the use of transient graphics. I have the ability to create, for example, a rectangle transient graphic over there of the selected color, or a circle. I'm going to draw a green circle. I can change the line type, I can make it filled, and I can as well update those existing transient by providing the ID. So by default, this rectangle is getting ID number 1, and I will update that transient using those properties. Inside the next sample, I was gathering a couple of miscellaneous functionalities. So we can, for example, load a JavaScript file here by providing the path. We can dynamically type some JavaScript code. In that case, I'm going to display this alert dialog. We can run the JavaScript. You can see the result of that code running there. We can show a modal dialog that contains an URL. Here is the Autodesk website. We can show as well task dialog, and we can grab the result of which button is being clicked. For example, in that case, the OK button. You can see here that the dialog result was OK button clicked, and a couple of other functionalities like logging into Autodesk 360, define a JavaScript command. Here I'm going to define the GS command. So when I type GS command there, you can see that my command has been invoked. This is the text output by my command. And we can as well execute AutoCAD commands synchronously or asynchronously. Here is the result of the synchronous command, and you can see here it was creating some lines in AutoCAD. So let's now switch to the third part of our presentation that discusses about how we can extend this JavaScript API. Because this JavaScript API has a limited coverage comparing with Object-RX or .NET, the development team was exposing a way to extend it to those languages. Here is how it works. From Object-RX, you will use the ACJS defunc method in order to register your RX callback and being able afterwards to invoke it from JavaScript. You will be able to use any Object-RX API inside those methods. From .NET, you will use the JavaScript callback attributes and provide the name of the callback you want to use in JavaScript. Let's take a look at the code sample. I was creating a solution that contains two projects, an RX1 and a .NET. And here is the test RX read method. This method will simply iterate through the model space and print the name of the object class entities we have. You can see that the method has a specific signature that takes a const sharp pointer as argument, that is a JSON formatted string. This will allow you to pass from JavaScript to Object-RX any parameter you may want. And as well it returns a pointer to char, that is a JSON formatted string that will allow you to return any value you want from RX to JavaScript. Concerning the write, we need to lock and unlock documents, as the method will be, the callback will be invoked at the application context. So before calling that method, we will need to lock our document and unlock it at the end. In that case, the method is simply going to create a circle and post it inside the database. Registration of those callbacks is done as follows, using this ACJS defunc, providing the name you want to use in JavaScript, your callback inside that RX, and a flag that can be one of those values. Concerning the .NET code now, the .NET code is very similar to the RX, except that is a .NET version of it. So you can see there is my test.NET read method that will iterate through model space and print the name of each entity. I use there the specific JavaScript callback attributes. And the same thing for the write method as well. From .NET, the lock is required in order to modify the database. So let's give a try inside AutoCAD, and for that I would need first to load my HTML page that allows me to write those callbacks. And obviously this .NET DLL needs to be loaded before invoking the callbacks from JavaScript. So I'm going to net load that DLL, as well as creating a couple of entities inside the database, polyline, and let's say a circle. I will now run the read method. As you can see here, the result of all the entities inside my database and the right method in order to create a circle. The last demo I wanted to show you illustrates at the same time extensibility and the real interest of the JavaScript API by using an online website invoking that JavaScript API. So here is the address of my online ASP.NET website I created for this sample, and by clicking that button that will take me to this website. You can see it there. The website has two different demos, the entity demo and the view demo. So let's take a look at the entity demo. I'm going to create some entities inside the database here. And I will then provide a group name. So when pressing the Save button, it will invoke the JavaScript API in order to select some entities. When selecting those entities, it will invoke callback function created in .NET that will grab the XF code of those entities and send it back to the JavaScript. The JavaScript will then store those values on a cloud table and being able to reload them in a different drawing. So I'm going to create a new drawing now. You can see the group I've saved previously, and when pressing the load group button, this will grab those values from the cloud table, invoke my .NET callback in order to create those entities based on the DXF code, and you can see those entities here I loaded from the cloud on a new drawing. That's pretty much the end of this presentation. I hope you enjoy it, and I wish you good luck in order to start developing your JavaScript web-based application. Thank you very much for attending this presentation.